actually pretty good. It tastes like spicy garlic. Okay.
Now, what we're continuing with is logarithms. All right, guys, so what we're talking about today is continuing on with our logarithms and exponentials, mainly our properties of logarithms. Now, there's three main properties of logarithms that we're going to be looking at today: product, quotient, and power. Now, the product property says if we have two or more things being multiplied together, if we have two things being multiplied together inside the log, we can write it or rewrite it as a sum of two logs. So if we have log of m times n, two things being multiplied together inside the log, we can rewrite it as log base b of m plus log base b of n. Our quotient property says if we have two things being divided inside the log, we can rewrite it as two logs being subtracted. And our power property states that if we have a term to an exponent of power, we can move that power to the front. So what this looks like for this here, so our product property, in simple terms, is that we could say log base 7 of 3x. So we have two things being multiplied together inside the log. We can rewrite it as a sum of logs. So we'd say log base 7 of 3 plus log base 7 of x. Because our two terms being multiplied together inside the log is 3 and x, so we can rewrite it as log base 7 of 3 plus log base 7 of x. Questions on how this product property works? Okay, let's look at the quotient property. So we could say log base 9 of 4 fifths. So the two things being divided inside the log are 4 and 5. So what we could do is rewrite this and expand it to log base 9 of 4 minus log base 9 of 5. Top minus bottom. The last one we can do is log base 3 of 3 to the x. Now, according to our power property, we can move that exponent to the front telling us that we have x times log base 3 of 3. Questions on this so far? So we kind of see how these properties work going from one to the other. They're really expanding. Now the last one actually can be simplified a little further because log base 3 of 3 is just 1. So it actually is just x. Log base 3 of 3 to the x ends up being x. But that's how we do that power property. Now the first thing we're going to be going over with these properties is expanding them. We're going to be given a single logarithm and we're going to expand it all the way out. Now, out of all the ways to expand it, the best order to apply these properties that I have found is going to be starting with quotient, starting with our division. We want to simplify the division first. And once we finish doing that, we'll go to product and last powers. So we'll apply the quotient property first, product second, power third. Quotient, product, power. And interestingly enough, and it's good to note, is that anything that's going to be on the bottom of the fraction with our log should have a minus in front of it. It's a way to signify that it's going to be in the bottom of the fraction. So, questions on this so far? Let's look at the first example. They tell us, and they want us to expand the natural log of 5x to the 7th over y. Natural logs and logs are going to work the same way. So the first thing we want to apply is our quotient. So the natural log of m divided by n is equal to the natural log of m minus the natural log of n. This is our quotient property. Now for us, we'll have the natural log of what? Well, m is what took the place of m. 5x to the 7th. Even though we have more than one term, we have the 5 and x to the 7th, it's on top, so it's going to go first. Minus ln of y. Y is on bottom, it's going to go second. Questions on this here? We took care of the quotient property. Now we can go to product. The natural log of m times n is the natural log of m plus the natural log of n. Now the only log that we actually have a product is the first one, the natural log of 5 times x to the 7th. And if we apply this product property to it, we'd have the natural log of 5 plus the natural log of x to the 7th minus the natural log of y. Questions? Only property left is our product, or our power property. Log base b of m to the n is n times log base b of m. We take that exponent and move it to the front. And the only one that has an exponent is our middle term. We're going to be moving that 7 out front. Natural log of 5 is going to stay the same. Our 7 move out to the front, telling us that we have 7 times the natural log of x minus the natural log of y. Questions on this so far? Now, as we look at each of those logarithms, the number inside, so we have 5x and y. There are no exponents left. There's nothing being multiplied together. This is fully expanded. And that's it. We know our signs are right because everything that should be in the top are 5 and x. Their logs are positive. Y is the only term in bottom, and it should have a negative in front of it. It does. That's it. So a lot of what we're doing today is just following these properties of logarithms, expanding, and we will be condensing too. So if we look at the next one, expand the natural log of 3x to the 5th divided by y. And again, we'll start with the quotient. This would be the natural log of 3x to the fifth minus the natural log of y. Our quotient, the natural log, or log of the top minus log of the bottom of that fraction. Log of the top of the fraction minus log of the bottom. Questions on this here? Our next is going to be product. Now, natural log of y, there's nothing being multiplied together besides y and 1, so we don't do anything with it. 3x to the fifth. Well, we do have two terms. We have the 3 and x to the fifth. And lastly, we're going to apply our power property and move the 5 up front. Like I said, we have the natural log of 3 plus 5 times the natural log of x minus the natural log of y. Questions on this here? We're ready for the next one. All right. We're looking at number 5. Log base 6 of 3x to the fourth. So again, our first property we are going to apply is quotient. Is there something being divided here? Doesn't have to be. There's not always going to be all 3. Since there is no division, we move from quotient to product. Now we do have two things being multiplied together, so we can rewrite it as a sum of those terms. Questions on this here? Questions? Questions? Now, it doesn't have to be restricted to just two terms, because if we said we had z to the fourth also, well, because we can add as many terms as we want. If we have 6, 7 things being multiplied together, we would add that many. Now, since we've taken care of product, now the last thing we have is power. So we just need to move that exponent to the front. So this 4 is going to move to the front here. Telling us that we have log base 6 of 3 plus 4 times log base 6 of x. Questions on this here? Let's look at number 6, the last one we're going to look at expanding. Now this one does have a quotient, so we'll start with it. So we'll have the natural log of the top, which would be the natural log of 5, minus the natural log of the bottom. So our quotient property would tell us that the natural log of 5 over 12x is the same as the natural log of 5 minus the natural log of 12x. Questions on this so far? Natural log of 5 this time, our first term, doesn't have a product. It's just a single term. So we just have natural log of 5. But the natural log of 12x we can rewrite as what? The natural log of 12 plus the natural log of x. I have to have parentheses. Because again, if it's on bottom of the fraction, it needs to have that minus in front, yes? So when we apply this here, we're really saying that the natural log of 12x is the natural log of 12 plus the natural log of x. That's our product property. But because it's in the bottom, it has that negative in front of it. That negative is not being applied to just the natural log of 12. It's also being applied to the natural log of x. Both of them are going to have that negative. So we have to put parentheses around it when we do that to distribute both. Because if it's in the bottom of that fraction, both of those logs are going to be negative. Each term in the bottom of the fraction, that is in the bottom of the fraction, its log is going to be negative. So we need negative natural log of 12, negative natural log of x. Does that make sense? I will take either form here, especially with expanding. If you put it in the parentheses or with the minuses out. Both of them are the same. If you have the parentheses or have the negative distributed. But if you don't put the parentheses, that natural log of x is going to need to be negative. Questions on this here? Questions on expanding? We ready to condense? So condensing, we're going to go the other way. And when we condense, the first one we're going to do is powers. And after powers, we're going to do product. And for a while, I would say quotients would be last. Now, again, I want to give you ways to do this and go over ways to do this that work for all of them. Now, the ones that get a little tricky are like the last one here, where we have these two terms that are both negative. Because this still works, we could do powers, there aren't any, and then product, well, we could factor the negative, we'd have to factor that negative out to redo the product and go from there. But I found something that's a little bit nicer. As a part of our power step, we're going to take the negatives back into exponents. Even if that means that we have an exponent of -1. It's going to make it a little bit nicer. It's going to remove the quotient step. And we're only having to worry about powers and products. And it's going to make a little more sense when we see it here. And especially if we have more than two terms. So when we condense, we're bringing it back together. We'll have a single log. So for the first one, we have log of 9 plus 3 log of 2 minus log of 3. Now log of 9 doesn't have a number in front of the log, so there is no power property to use. In the middle, we'll pull the positive 3 up, put it back to an exponent, telling us that the middle one is log of 2 to the third. So we're going in reverse. Our power property said that if we have an exponent inside the log, we can move it to the front. We can also take that number in front and move it back to being an exponent. Now the last one here, we said we're taking the negatives also. Well, the number in front of log of 3 is negative 1. So what we could do for this last one is write it as log of 3 to the negative first. We can take those negatives with it. Now, if it had been minus 2 log of 3, we'd take it up as negative 2. We take the number in its sign. But what would that mean for the sign in front of this? It would become what? Positive. And the nice part about this is now our quotient, where we have 2 logs being subtracted, would be rewritten as a fraction or division inside. We don't have anymore. It's all plus. It's all product. Because if we have 2 or more logs with the same base being added, we can write it as a single log with what was inside of each of the logs being multiplied together. Now, the only thing we have to do at this point here is simplify what's inside the log as far as we possibly can. We're not going to get an actual value for this. We'll have an expression. But one of the main things is any term that has a negative exponent, we need that exponent to go back to being positive. Since 3 is to the negative first power, well, we can move it from the top of the fraction to the bottom. And it's going to turn that negative 1 to a positive 1, so 3 to the first, or we can just say 3. On top, we still have the 9 times, well, 2 to the third is 8. Well, 9 times 8 divided by 3, that's simplifiable. Well, 9 divided by 3 is 3. 3 times 8 is 24. So log of 9 plus 3 log of 2 minus log of 3 is the same as log of 24. Those will give you the exact same value. Questions on this here? All right, we're going to look at the next one. Log of 6 plus 4 log of 3 minus log of 3. I have a feeling they just give me an answer. Yep. There's 2 different ways. There's a different way we could do this, and that's just because how it's set up. But we'll do it the way we just did it. Powers first. Log of 6 does not have a number in front of it that we can return to an exponent, return to a power. So it's going to stay log of 6. The middle one, that 4 out front, we can return it back to an exponent, telling us that we have plus log of 3 to the 4th. And the last one, we can take this negative 1 and put it back, plus log of 3 to the negative first power. Questions on this so far? Now at this point here, we have 3 logs being added together, so we can rewrite it as a single log with what's inside it, our terms being multiplied. 3 logs with the same base being added together can rewrite as a single log with what's inside of each of those being multiplied. And now we can simplify it. Now, looking at this here, the numbers inside of our log, well, we have 6, 3 to the 4th times 3 to the negative first. Do we have any variables inside that log? So is there anything restricting us from just grabbing a calculator and saying 6 times 3 to the 4th times 3 to the negative first. No. If we did have variables at this point, I'd be making sure to get all of our exponents back to being positive, moving the 3 to the bottom, 6, 3 to the 4th is 81, and simplifying. Well, 6 times 3 to the 4th times 3 to the negative first will get us, it will tell us it's 162. Questions on this here? One thing I do find interesting is we could have just subtracted these from the start. Because I have 4 log of 3, and I take away a log of 3. We have 3 logs of 3. Yeah, we could have just subtracted. Okay. Questions on any of this so far? Now, I will say that doing this power and taking the negative, for most, a lot of them does make it a lot nicer. Not all. If we look at this next one here, we'll do it by this here. Log of x for powers. There's not a number in front of it. We can't take any exponent back up except for 1. However, our log of 9, because it has the minus in front, we can take the negative 1 back up and tell us that it's log of x plus log of 9 to the negative first. Questions on this so far? We have 2 logs being added, so I can rewrite it as a single log with what's inside being multiplied. Now we do have to fix the negative exponent, so take the 9 from the top of the fraction to the bottom. Okay. Questions on number 7? Now, number 7 is one of the cases where this taking the negative power isn't the most efficient way to do this. Because what I just wrote up on the board, log base b of m minus log base b of n is equal to log base b of m divided by n. That's just quotient property, yes? So if we look at this here, we have 2 logs being subtracted, yes? I'm going to erase all that and try to. There we go. Well, the base is 10, so we can just say log, yes? I took the place of m for this here. I took the place of n. So just according to the quotient property, 2 terms log of x over 9. So again, there are some cases where this is nicer. And especially when we just have 2 terms being subtracted, quotient property just works nicer and we get there. Our other way will work, and it works better, especially if we have more than 2 terms. We have terms that are being added and multiple being subtracted. But if we have 2, we just apply quotient, we're done. Questions on this here? Let's look at the last one, the natural log of 4 plus 3, natural log of 3 minus the natural log of 12. Powers. Well, the natural log of 4 doesn't have an exponent we're putting back. The middle one, we're moving that exponent of 3 back, giving us 3 to the 3rd. And with our natural log of 12, we can take that negative and throw it back on top, back in the exponent. Since we have three of the same log being added together, we can rewrite it as a single log with our terms inside being multiplied. 4 times 3 to the third times 12 to the negative first. 4, 3 to the third, 12 to the negative first. Four times 3 to the third times 12 to the negative first is 9. Because really all this is saying, and I'll write it out, is that 12 to the negative first would go on bottom, giving us 4 times 3 cubed over 12, yes? 3 cubed tells us we just have 3 multiplied by itself 3 times, yes? So really we have 4 times 3 times 3 times 3. What's 4 times 3? So the 12 on top and bottom will cancel, leaving us with just what? 3 times 3, which is 9. It seems odd that it would work that way, but it kind of does. It works nice. Questions on this here? Questions on any of this so far? Now the question is why is this important? Or why was, well, it's going to be more why was this important? Because there's so much in mathematics and stuff that we do today that has just become outdated. Because as we've seen already, graphing calculators, we have calculators that can actually evaluate log of any base. However, that's not always been the case. Because at a certain point, for us to be able to evaluate any of these logs, we actually had to look at a table. There was actually printed tables of logarithms with certain bases. They're not going to print every possible log base 2 imaginable. They only had to print a certain number because of these properties of logs. So they could give us, say, log base 2, and the number inside of it can go from 1 to, say, 10. And they gave us two of them, log base 2 of 3 and log base 2 of 7. Now they sure would not put log base 2 of 3/7 in any of the tables. Because according to our quotient property, log base 2 of 3/7 is the same as log base 2 of 3 minus log base 2 of 7. Because I can take that according to the quotient property. If I have two things being divided inside the log, I can rewrite it as a subtraction of two logs. So if we subtract these here, well, log base 2 of 3, I can look at the table, and it's 1.585. Log base 2 of 7 is 2.807. Now all we have to do is subtract the 2. 2. 1.585 minus 2.807 is going to be negative 1.222. And this is kind of nice because now we don't need every possible log base 2. We can reduce the number. Now log base 2 of 21. Well, we can use 3 and 7. We can say what? 3 times 7. And if we have a product of 2 or more numbers inside the log, we can rewrite it as a sum of logs. And again, at this point, we would look back at the table and see that log base 2 of 3 is 1.585. Log base 2 of 7 is 2.807. So really, we've turned this exponential logarithmic equation into just look at a table and add the numbers together. There's 2, 1, 9. 4.392. So that means with our product property, really, as long as we have the prime numbers, we can get any composite. So there's no reason to have, say, log base 2 of 4 listed on the table. 4 is just 2 times 2. Or log base 2 of 6. Because as long as I have log base 2 of 3 and log base 2 of 2, I can get log base 2 of 6. Or 8, or any of these here. So it's making the amount that we have to print, or these tables we have to build, smaller, more manageable. Last one for this set here, log base 2 of 9. Well, 49 is what? 7? 7 times 7, or 7 squared, yes? Well, this here, we can move the 2 out front. Let us say we have log base 2 of 7 times 2, or 2 times log base 2 of 7. And log base 2 of 7 is 2.8. .614. Questions on this here? We will finish these tomorrow.